This is a reminder Class Connect sessions are recorded and distributed for learning purposes listed here. As always, be respectful, appropriate, and participate, but please don't share personal information like how to contact you during the session for your own security reasons. So here we go. On the whiteboard, what I would like you to do is I'm going to have you guys today, you're going to have an extra credit discussion that you're going to be doing. So it's time to start finalizing your decisions, right? So we've been talking all about habits and goals, and now it's time to like firmly put it in place for quarter number 4. So I want you to either point to, which means that you can use this tool, the second tool, or you can use the sticker tool, which is the one at the bottom. All right, so you can choose your sticker here at the bottom. So go ahead, point or put a sticker on the category that your SMART goal that you have decided on, that you want to focus on, falls into. Again, we're only going to focus on one in my class, so don't try to put stickers everywhere. Just go ahead and choose one of these that you're going to be looking at, right? So these are the ones that I've talked about already, right? Logging in, checking grades, making a to-do list, attending more live classes, responding to emails, writing down what you've learned, or you could choose your own student goal. You can also do life goals, right? It doesn't have to be student-centric. I know a lot of you are already great students, so maybe there's another area of your life that you want to improve, right? Waking up on time, going to sleep on time, becoming more positive, becoming more mindful, improving exercise or food choices, or choose your own life goal. All right, so go ahead, get your answers up there. I'm going to go ahead and see who I've got up on the board. Just want to see where everyone's kind of thinking. Awesome. I see Justin on the board, Efren and Orlando and Noah. Awesome. Thank you for getting your answers up there. Looking good. Exactly, Efren, right? So if you are already doing some of these things, that's great. Obviously, then you want to focus on something new, right? If we improve different areas of our life, right? Awesome. I see Ireland and Valeska on the board. I love it. I see a theme going on under life goals. Dorian, cool. Dorian, go ahead, tell me in the chat box exactly what you're kind of thinking for your choose your own adventure. Awesome, looking good. Oh, I see a sticker from, let's see here. Oh, sorry, I see Amanda and Jody. Love it. Good, good, good. Thank you, everyone. Yes, get your answers up there. Again, just put a sticker or just point to where you are. You could also draw a check mark like Efren did. That's also super good. Awesome, awesome. All right, looking good. I'm going to go ahead and take a look at what we're kind of thinking about. You can definitely still get your sticker or your pointer up here because I'm still interested. But it looks like a lot of us, if we are under school goals, we're trying to think of like logging in every day, checking your grades, or making a to-do list, both of which are really great things. They're also super simple. Tell me in the chat box, how long do you think it takes to do these two things, logging in or making a to-do list? How long do you think that really takes? You think it's going to be like an hour-long effort? Go ahead, tell me in the chat box. How long realistically do you think these two things would take? Awesome. I see someone saying emails is going to be a focus for them. Another person saying live sessions is going to be a focus. Oh, you did. Awesome, Dolly. I'm so happy to hear that. Keep up the great work, right? And then you get to start crossing things off of your to-do list and it feels awesome. All right, good. Yeah, so these two things, they only take like 5 minutes, right? Making a to-do list is really fast. Logging in, checking your grades is really fast. So again, these goals don't have to be Herculean, like Hercules. They don't have to be these crazy efforts, right? Make it simple. Make it something that you can easily do because once we start getting that momentum, then we can start doing bigger and bigger things. Awesome. Life goals. I see some patterns over here. So it looks like we're going to work on waking up on time and following a routine. The best thing I can that I can recommend to you is science has shown that if you wake up and make your bed, as horrible as that sounds, because I was once a teenager and hated making my bed too, but if you make your bed, it actually affects the entire rest of your day and makes you more productive. All right. So just that one simple little act, again, a tiny thing that'll take less than 5 minutes of your time can help your day be so much better, right? Writing down positive and grateful thoughts, that's a great one, right? Sometimes it's just very easy for us to kind of get in our own brains and like if we become negative or become depressed or become upset, right? So if you just remind yourself that there are things to be positive and grateful for, just one sentence can really help your day get a little bit better, right? Improving exercise and food choices, awesome, right? Both of those things are also, science has shown that as you improve exercise and as you improve your food choices, the rest of your life actually also improves, right? Because you have more energy, you're happier, right? Because you're a little bit healthier, and that actually helps you accomplish other goals too. Or if you have your own life adventure, tell me in the chat box. I want to know what your own adventure is as well. All right, love it. Thank you guys. Okay, so I'll talk a little bit about how you're going to get your extra credit today, but again, we're solidifying this. We're making a decision today. We've been talking about it for a week. So we should be in our attendance ticket. Give me a green check if you've got it ready to go. There are 2 links down there. Remember, one will work, one won't. Choose the one that does. And then the password for today is also there. Let me know if anyone's having trouble getting in. Looks like everyone's giving me green checks, so looks like we're not having any link issues. Love it. Okay. So we are on day 6 of quarter number 4. We're at the end of our first real week, right? Last week, I count that as week 0 because there was only 1 day. So we're at the end of our first week. There's only 8 weeks left of school, and then it's summer break. So today we are starting unit number 2, talking about the states of matter. Okay, so here we go. Remember, we've already talked a lot about how you can get extra credit through support sessions. How many support sessions do you need to attend each week to get a total of 5% extra credit by the end of the quarter? How many support sessions should you attend each week to get extra credit? Tell me in the chat box. Awesome, I see Noah typing, I see Dolly typing, Israel typing. There we go. Yeah, give me your best guess. All good? All right, yeah, it's actually just 1. So currently there are 3 support sessions that you can attend, but you actually only need to go to 1 of them to get your extra credit, and it really only takes you about 5 minutes to get that extra credit. Smiley faces if that makes sense. So this is a super easy way to get your extra credit and to check in with me about your grades. So I just want to make sure that you guys are coming to support once a week, 5 minutes of your time to get that extra credit. Now here is the other 5% of your extra credit, because remember, there's a total of 10 possible. So the other 5% is through these discussions that we will be doing. All right, so you're going to get a chance to kind of chat with some of your classmates, as well as kind of, again, solidify your own choices of what your goals and habits are going to be. So the other 5% is from developing goals and habits throughout this quarter. So in this discussion thread, what's going to happen is, in order to get full credit, you need to be respectful and appropriate. To the best of your ability, try to use correct grammar and spelling just so that everybody understands you, okay? You're going to write your answer to the prompt, which will take about 3 sentences, and then you're going to respond to 2 classmates, about 1 sentence to each of them. Smiley faces if you understand. So it's really, really fast. It shouldn't take you more than like 5 minutes to do. These are super fast. Again, this is just kind of your check-in each week to make sure that you are working with your habits and goals. Awesome. So for this week, we are going to write our final SMART goal for this quarter. It can be either school related or life related. Just choose one though. And then you're going to respond to 2 other people to encourage them with their goal. Exactly. Yes, Efren. And then just remember, you can have fun with your classmates, right? You can joke around with them. But as long as you're being kind, as long as you're being school appropriate, I am fine with that. Okay. So remember, if you're in doubt, don't post it, okay? So just be kind, be school appropriate, you can have fun with it, okay? All right, so let me go ahead. I'm going to screen share what that looks like. That's exactly what that means, Efren. All right, so let me go ahead and screen share this with you. Hi, Arrow, great to see you. How are you doing? Glad you were able to make it today. Let me screen share this. Okay, so here we go. You can see here underneath the plan that you can see the week 1 extra credit discussion. So you can access it from there. I can also send you the links for today, but I don't do it right now because I want you to focus on class right now. But if you want the links for later, you can have that. The other way, as always, the best way to get all of your stuff is under the grades tab. So if you go to the grades tab, you can actually see the links to the discussion right here. Okay, so the week 1 extra credit discussion, you're going to click on that, and then here we go. It's going to have you say, what is one of your SMART goals? And then respond to 2 of your classmates. So I have a little template right here for you. Literally just highlight it, copy paste it, and then fill it out, okay? And then you're going to start a new thread, and that's where you're going to put this, okay? So you'll start a new thread, and then you'll copy paste this, which it's in the student view, or it's in the teacher view. Hold on, let me see if I can do the student view. Student view might be a little bit better. Sorry, guys. No worries, Efren, you're good. Okay, so you're just going to highlight this and then copy and paste it, right? So copy this, start a new thread, and then you're going to paste it. Paste it, and you can just enter your subject, which is week 1 extra credit. Okay, this template at the top. All right, so when you click on the week 1 extra credit, which is right here, Efren, it's in the grades tab, or it's in your class plan for today. Yeah, just this stuff right here. These are just examples. You can't highlight this because it's just a picture. So just highlight where it says specific all the way to timed. Right? So SMART means specific, measurable, attainable, relevant, and timed. All right, and I have examples here. Be as specific as you possibly can. Give me as much detail. Right? So an example was I'm going to log into K-12, access all of my classes, look at my grades, measure it. I'm going to measure it by doing it every day. If I do it every day, then I've done it correctly. Attainable, I already log in most days. I just forget to check my grades, so this is not a big step, right? Again, we want to think small and attainable. Relevant, it'll help me become better because I'll be more aware of how I'm progressing in every class. And timed, I'm going to do it right after I eat breakfast at 10 a.m. for 5 minutes. Okay, smiley faces if that makes sense. If you have a life goal, I have another example over here. But again, the more detail, the better. If it's missing too much detail, I won't be able to give you your full extra credit. So just give me as much detail as possible. Perfect, guys. All right, thank you guys for taking a look at that. Let's go ahead and jump into today's topic. So today we're going to talk about phase changes and how that affects our states of matter. So we're going to talk about the 4 states of matter. We're going to explain how molecules behave in them, explain how you can absorb or release heat when you change phases, change between those different states, and talk about the kinetic theory of matter and how that's related to gases, because we have an entire unit coming up all about gases. Okay, so here we go. Let's talk about the 4 states. So remember, matter is anything that has mass, okay? Sorry, I'm going to grab these links here. Anything that has mass, so everything around you, right? The air you're breathing, the ground you're standing on, the computer you're using. Yep, no worries, Efren. It'll make more sense. Here, Efren, I can send you the links to the discussion again. Oh, sorry, I did just send the links to the discussion. My bad. Okay, here are the discussion links. And then the instructions are all there for you, okay? So if you're still confused, though, definitely check in with me, okay? Cool. Yep. All right. So matter is anything that has mass, and there are 4 different states or phases that matter can be in. Okay, so this is how matter acts based on its environment. So it can be a solid, right, which means that it's going to be held firmly in place. It can be a liquid, so it can flow. It can be a gas, so that it can spread out into the atmosphere, or it can even be plasma, which we're going to talk about is a pretty cool fluid as well. So let's dig into those. Solids hold their shapes, right? Think about your solid computer. Does your solid computer keep its shape, or does it start flowing all over the place? Tell me in the chat box. Think about your computer. Hopefully, yeah, it all stays in place. Hopefully it doesn't start leaking through your fingers, right? It keeps its shape. So solids specifically have a specific volume, which means amount of them, as well as a specific shape. Their shape does not change. Smiley faces if you understand. Solids hold their shape, and they also maintain their same amount. Right? If you have one computer, you're going to still have one computer. Okay, now the reason for this is because their molecules have a very little energy, or what we call thermal or heat energy. And so they're kind of like cold molecules. And if they're cold molecules, they just kind of vibrate in place. They don't have enough energy to move. Okay, no worries, Israel. Cool. So for example, ice in your freezer, okay, it maintains its shape, it maintains its volume. That does not change, right? It stays as a square or a cube or however your ice is shaped in your freezer. And the amount of ice does not magically change, okay? Now, liquids, on the other hand, liquids do change shape. They take the shape of the bottom of their container. So the liquids, however, you still have a specific amount, right? Let's think about this, guys. If I have a cup of water, okay, and I move it to a different container, do I still have a cup of water? Tell me in the chat box. If I have a cup of water and I just move it to a different container, do I still have a cup? Yeah, absolutely. Okay, so I still have the same amount, the same volume, but its shape can change, right? Liquids can go from in a glass to on the ground, all spread out, right? Yeah, they can change their shapes, okay? They change their shape to match the bottom of their container. Now, the reason for this is because their molecules have a little bit more energy, okay? So they have more heat or thermal energy, and so they have enough energy to start flowing past each other. So here's my example here, just to kind of solidify this in your minds. All right, so let's take a look here. I've got some oil. All right. And in one container, I'm going to go ahead and put half a cup of oil. All right, so you can see this here. I'm going to try to put half a cup. I don't know if I can see this since it's facing you. All right, there we go. So we have half a cup of oil. Now take a look at the level of this oil. Is this level of the oil kind of high or kind of short? Tell me in the chat box. I know I would end up spilling it all over my keyboard and I would be very sad. Is the level high or short? Tall or short? Currently. Tell me in the chat box. Yeah, I would say the level's pretty short, right? But now watch as I pour it into a different container. Wait, hold on. Okay, so here's my other container. I'm going to go ahead and pour it in. And now tell me, has the level gotten taller or shorter? Has the level gotten taller or shorter? Taller, right? So its shape has changed. Smiley faces if that makes sense. The shape of our fluid has now changed, right? It got taller. But is there still half a cup of oil here? Even though it changed its shape, is there still half a cup? Yes, the total amount of oil did not change, because otherwise that would be awesome. I would just keep on pouring oil into new cups and suddenly have an endless supply of oil. Okay? All right, now the next one we need to talk about is gases. Okay, so gases have no definite shape or volume. So gases are even crazier. Yeah, so you can think of smoke, you could think of steam, right? So you could think of oxygen, right? The air that you're breathing, nitrogen, okay? So changing the temperature or pressure of a gas can actually change its volume. So when we're talking about amount, we're really talking about the amount of space it takes up. So if we change the temperature or pressure of a gas, we can change the amount of space it actually takes up. So gases are going to try to spread out to fill their entire container, right? Liquids are kind of stuck at the bottom, but gases actually have so much energy that they can totally escape from each other. And so they're going to, with all of their energy, they're going to try to escape and expand as far and wide as possible. So you can see here, gases will actually keep on expanding, taking up more and more space or volume, and they don't keep their shape. They just spread out kind of like clouds or smoke. Smiley faces if you're beginning to understand that. Smiley faces if that's beginning to make sense. Awesome. All right, so just keep in mind that it gets more and more chaotic, basically, right? Solids, fixed shape, fixed volume. Liquids, fixed volume, but their shape can flow around and change. Gases, all over the place, chaos, okay? Yeah, absolutely, Efren. So gases, because they're made of molecules, you can actually have too much gas in a box, and they will try to press out so much because they have so much energy that they can actually cause the box to explode. This is what happens, for example, when a propane tank gets heated up when it shouldn't get heated up, and then it can explode. That's a great question. All right, the last type is might be one that you haven't heard a lot about. So the last one is what we call plasma. And plasma is actually the most common state of matter in our universe. It's just that we don't see it very often on Earth because the place that it happens the most is in the sun and the stars. But most of our universe is made up of stars. Okay, so that's why plasma is the most common, because most of the universe is made up of stars. Smiley faces if you understand. So it's found in sun, in stars, it's found in neon lights, it's found in lightning. Okay, so here's the cool thing about plasma. So plasma has some properties similar to gas, but it's also really neat because its electrons are actually, its molecules have so much energy that its electrons can actually move completely freely from their atoms, which is different than the other states. So these electrons can actually move away from their other atoms, and the result is that these gases can actually conduct electricity and be controlled with electric charges. Yeah, so again, the main idea here is plasma, kind of like a gas, but the electrons can actually move away from their atoms. No, sorry, Efren, I said most of the universe is made up of stars, right? The amount of planets compared to the amount of stars, right, would like the mass of stars would be different, right? There's a much larger mass of stars than planets. Good, good, good. Okay, perfect, guys. All right, let's go ahead and match these up. Let's make sure we understand these, right? Liquid, gas, plasma, solid, right? Electrons can flow freely. Definite shape, definite volume, that means fixed, stays the same. Indefinite shape means it changes, definite volume, fixed. Indefinite shape, indefinite volume, they can both change. Go ahead, match those up. Please use thin lines. Please use any color but red, because that's the color I'm going to use. Looking good. Hi, Donnie. Welcome to class. Open up your ticket. Hi, Letty. Great to see you. Go ahead, open up your ticket. Password is awesome. Love the participation. We are on it today. We are ready to finish strong for the week and go into our weekend feeling confident. Love it. All right. Thin lines, guys. All right, looking good. I'm going to go ahead and pause your tools in about 5 seconds. Keep on going, keep on going. Let's see who I've got on the board. See Dolly and Amanda and Efren and Dorian and Jody. And let's see here. Noah, keep on, and Alicia. Thank you. Love that participation. Cool. All right, I'm going to go ahead and pause these. I'm going to shrink these down. Looking good. All right, awesome. So liquids, let's take a look at this. Liquids, you are correct, have an indefinite shape, right? Because, I don't know, they have an indefinite shape because they can flow around freely, but they still have a definite volume. You can't change the space that a liquid takes up, the amount, right? Gases are chaotic. Gases have both an indefinite shape and an indefinite volume. Plasma is where we have electrons that can move freely. And solids have a definite shape and a definite volume. They're the least chaotic. Okay, this is number 1 in your ticket. Go ahead and give me a green check when you have number 1 saved. I'll go ahead and give you 40 seconds to work on that. And then I have started adding these, this attendance ticket question will be related to number 1 and number 2 in your quiz. All right, need some more green checks. As always, if you find it's going by a little bit too fast, feel free to take a picture. And as long as you save today's password, you can always finish it later. Awesome. Waiting on a green check from Amir, Tony, Bree, Chanel, Dolly, Dusty, Donnie, Dorian, Dree, Dylan, Isaiah, Ethan, Ireland. Thank you, thank you, thank you. Love it. Letty, Matt, Oscar, Tristan, Whitney. All right, let's keep on going. All right, guys, so we've got a lot of stuff to go through. So we're in our next topic. We still have one more topic after this. So this is all about how we can actually change between those different states we just learned about. Solid, liquid, gas. We're going to learn about how we can change between them. And these are what we call phase changes. Okay, smiley faces if that makes sense. So the word states of matter, you can also say phases of matter. So you could either say a state change, right? But really, we tend to call it a phase change, right? So we tend to say phase change more than a change in the state, okay? All right, so to change matter between the different states, you have to do something with the energy, okay? I mean, Efren, you're always welcome to take notes on your own, but remember this will always be in the videos for you as well. So you don't have to multitask if that's too distracting. All right. So energy has to either be absorbed or released to be able to change the matter between solid, liquid, gas. Okay. So when we absorb heat into something, meaning that you're adding heat into it, this is what we call an endothermic reaction or an endothermic process. So for example, to go from solid ice to liquid water, think about this. Liquid water, is it hotter or colder than ice? Tell me, is liquid water hotter or colder than ice? Everybody in the chat box. Is liquid hotter or colder than ice? Liquid water. Awesome. I got an answer from Dolly. I see Valeska typing. I see Dorian typing. Efren typing. Yeah, the liquid is going to be warmer. It's going to be hotter than the ice, right? Ice is really cold. So ice is cold, right? Water is warmer. And then steam, water vapor is the hottest. That's why we don't put our hands over boiling water, because the steam can actually burn you. Okay. So that being said, when we get warmer, all right, things like melting ice into water or evaporating water into gas, these all are adding heat to the molecules to make them speed up, to make them hotter, and this is an endothermic reaction. Okay, thumbs up if that's starting to make sense. We're going to get lots of practice with this, but I just want to make sure that you overall are beginning to understand. Now, on the other hand, if you release heat or heat is subtracted from it, this is going to be something like freezing or condensing, right? So if you go the opposite direction and get colder, going from hot steam to warm liquid, that's going to be exothermic. Or if you get even colder, going from liquid water to ice, that is also exothermic. It's releasing heat and getting colder. Okay, releasing heat and getting colder. Cool. All right, so let's go ahead and actually practice this together. So let's think about condensation, which is like when on a hot day, if you take a cold glass of water outside, that you suddenly get these droplets on the outside of your glass. How many of you have ever seen that? Okay. And it like leaves a ring on wherever you're sitting or wherever it's sitting. Yeah, exactly. So this is what's called condensation. So what's happening is the gas in the atmosphere is condensing into a liquid on the outside of your glass. Okay, so let's think about this. If we're going from a gas to a liquid, is the water getting warmer or colder? Tell me in the chat box. If we're going from gas to liquid, are we getting colder, warmer, or colder? Everybody in the chat box. Think about steam versus liquid water. Steam versus liquid water. Yeah, we're definitely getting colder, right? So we're getting colder. And in that case, sorry, I'm going to actually do it this way. We're getting colder. So in that case, do you think the molecules are moving faster or slower? Okay, if the molecules are getting colder, are they going to be moving faster or slower? Yes, they will be moving much slower, exactly. And so if they're moving slower, right, do you think that they are absorbing heat, getting more heat, or do you think they're releasing heat, getting less heat, right? Think about getting colder, getting slower. Are you absorbing heat, getting extra heat, or releasing heat, losing heat? What do you guys think? Yeah, we're going to be releasing heat, exactly. And so releasing heat, which of these is this going to be? Is it going to be endothermic? Endo, the prefix endo means into, or is it going to be exothermic? The prefix exo means exits. So do you think the heat is going into endothermic or exiting exothermic? What do we think? Tell me in the chat box. Yes, perfect, exothermic. Love it. All right, let's go ahead and try this next one on the other side. So the opposite process is evaporation, where we go from a liquid to gas, or like when you boil something. Okay, so in this case, what happens to the substance? Is it getting warmer or colder? Going from liquid water to gas, think about going from liquid water to steam. Yeah, definitely getting warmer. Awesome. So those molecules, if they're getting warmer, are they going to start moving faster or slower? Faster or slower? Definitely faster. They're going to speed up because they're like, I got energy now. I can move faster. And so are they absorbing, getting extra heat, or releasing, losing heat? Absorbing. And that means heat, it's going, is it going into endothermic or exo exiting? What do you think? Endothermic. Love it. How are we feeling about this? Give me a, let's see here. Give me an LOL face if you're feeling good about this. All right. Give me a thumbs down if you're feeling too confused. We're going to still get a little bit more practice. So don't worry if you're like, I'm not 100% yet, Miss Larkin. That's totally fine. Perfect. All right. So let's go ahead. Let's see if you guys can do this one on the left yourself. So please use thin lines. All right. Use your box tool. All right. And go ahead and circle the correct terms here. So freezing, going from a liquid to solid. So like liquid water to ice. All right. Think about, does it get warmer or colder? Should the molecules get faster or slower? Should it be absorbing or releasing heat? And is that going to be endothermic into or exothermic exit? I know, I'm actually very thirsty right now. I'm going to drink some water. Oi, who's starting on the right side? I haven't said to do the right side yet. Slow your roll. Slow your roll. All right, looking good. Gonna pause your tools. Love it. You guys got this. Yes, you are correct. To get to a solid, you have to get colder. The molecules have to slow down, meaning that they're losing heat. They're releasing that energy. And since heat is exiting out, that's exothermic. Excellent job. Now do the right side. I believe in you. I'm sure you guys have got it by now. Melting means solid to liquid, right? Going from ice to liquid water. What do you think? What's happening to the temperature? What's happening to the molecules? What's happening to the heat? And what's that final word called? What's the definition of that? Oh, I like the color changes here. I like it. Nice. We got the green for the cold, or the blue for the cold on the left side, and the reds for the hot on the right side. Yeah, you're right. It gets warmer, they get faster, they absorb heat, and therefore those are endothermic. All right, how are we feeling? Tell me in the chat box. Are we feeling confident? Are we feeling like we're beginning to get it? All All right. If you have questions, always let me know. Looking good, looking good. Awesome. Okay, I feel like you guys probably get this now, but deposition is a really cool one. So a lot of times we're very familiar with those other ones, but this one is actually really interesting. So deposition is actually where it gets so cold so fast that a material goes from a gas immediately into a solid, totally skipping the liquid phase. All right, so it actually skips, let me put this here. So it skips the liquid phase. Okay, so the reason this is cool is like this is with frost. How many of you have ever walked outside and you've noticed that all of your like plants and stuff have little ice crystals on them? Maybe not in California. I don't know in which part of California you live. Oh no, biology is great too. I taught biology for a couple years as well, 3 years. All right, but how many of you have ever seen frost, right? Smiley faces if you've ever seen frost. So awesome. So frost is a type of deposition where it's depositing onto something. Deposition meaning depositing onto the leaves or whatever, okay? So this one should make sense because in this case, what's happening to the molecules? Are they getting hotter or colder? Warmer or colder? Tell me in the chat box. Are those molecules getting warmer or colder? Yeah, exactly. They're getting colder. So that's going to be all these things on the right, right? So that means, oops, whoa, what's happening? So that means it's releasing heat. It means it's getting slower, colder, and exothermic. Smiley faces if that makes sense. I'm sure you understand the pattern now. It's all the ones on the right. Awesome. Now sublimation, on the other hand, is the opposite, where it also skips the liquid phase. All right, so it's super cool, skips the liquid phase. Okay. How many of you have ever played with dry ice? How many of you have ever played with dry ice? Yes, dry ice is super fun. When you turn 18, you can buy it. Yes, it's lots and lots of fun. Let me see if I can find a video for it really quickly. I have a video of us playing with dry ice. Why is it called dry ice? It's called dry ice because it's literally ice that doesn't turn into a liquid. It immediately goes into a gas. So it's dry because it doesn't turn into a liquid. Does that make sense? All right, let me see. I've got... All right, sorry guys. I meant to get this set up earlier, but I forgot to. Okay, sorry. Yeah, the video's not working. Let's see here. Yeah, you should wear gloves. I mean, for the most part, if you touch dry ice for a couple moments, it's not going to hurt you, but it is so cold because they have to freeze it so cold that if you keep your fingers on it, it can actually burn you. Okay? All right, cool. I'm sorry, guys. The video is not working. But so taking a look at this, guys, yeah, it can give you a dry ice burn, or it can give you like frostbite. All right, so sublimation is going from a solid to a gas, so going from dry ice immediately into a gas because it gets hot so quickly, it totally skips the liquid phase. All right, and so in this case, it's absorbing heat. The molecules are getting super fast, getting very hot, and that is going to be endothermic. All right? Cool, everyone. Let's go ahead and match these up, make sure we understand these, right? So condensation, gas to liquid, sublimation, solid to gas, evaporation, liquid to gas, deposition, gas to solid. So here are some of the ones that we just learned. Think about what's happening to the energy, okay? Right, think about if energy is getting added or gained, right? Think about that's probably getting hotter. If energy is being subtracted or released, then it should be getting colder. All right, that should help you figure that out. No, dry ice is a ton of fun, guys. This is like you can put it into like drinks and it'll look like a witch's brew. All right. It's too much. I'm going to shrink these down. Too much, guys. Stop using thick lines, please. All right, there we go. All right, I'm going to go ahead and pause your tools here. Thank you guys for all of your participation. And I'm going to go ahead and shrink these, and let's take a look at our answers here. This is going to be number 2 in your ticket, so get that ready. Get that ready. And this will also be related to quiz questions 3 through 6, just so that you're aware of that. Okay. Here we go. So yes, condensation. Condensation means we're going from a gas to a liquid. So we must be getting colder. So we're losing energy. The molecules are getting slower, and that must be exothermic. Sublimation, on the other hand, is going to be going from a solid to a gas. So those molecules are getting really, really hot, really fast. All right. And so those are going to be getting more energy faster, endothermic. Evaporation also means the molecules are getting a little bit faster. Right, so that's also endothermic. And deposition, again, those molecules get cold really, really fast. They turn into frost on leaves, and that means they are getting colder, losing energy, exothermic. All right, how do we feel about that, everyone? Go ahead. You have, let's see here, 40 seconds to answer this one. Here's the password again in the chat box, Bree. If you guys ever need the password, just scroll up. I paste those links a lot, okay? All right, looking good. Green checks when you have this saved. All right, waiting on Amir, Tony, Ashton, Bree, Chanel. Green checks, please. Dusty, Donnie, Dorian, Dree, Dylan, Efren, Israel, Jacob, Jackie, Jessica, Justin, Letty, Miguel, Oscar, Rozzy, Tristan, Whitney, Yolese, green checks. And we're moving on in 5 seconds. And let's keep on going. All right, here we go. So usually we only have 2 topics for each class, but we do have a 3rd one today. So like I said, there's a lot of info today. So the last thing that we need to talk about is what's called the kinetic theory of matter. What does the word kinetic mean? Those of you that were with me last quarter, what does the word kinetic mean? Tell me in the chat box. What does the word kinetic mean? Awesome, I got an answer from Taylor. I see Dorian typing. Arrow's got an answer. Yes, it means motion or movement. Right? So when we're talking about the kinetic theory of matter, we're talking about how matter moves. So here's the thing. Atoms in all matter are in constant motion, and they all have some energy. Even things in solids actually are moving. You can't see it because we are so zoomed out, but if you were to zoom in on the atoms in your computer, they would actually be vibrating and shaking back and forth because all things have some energy. Now, the interesting thing is when molecules collide with each other, okay, because like molecules and gases and liquids, they will collide with each other, they don't actually gain or lose energy. They just transfer the energy, kind of like billiard balls, right, where when you hit one billiard ball, it begins moving, the other one stops. It transfers its energy. Smiley faces if that makes sense. It transfers its energy. Okay, and this has to do with what's called the conservation of energy, which we've been learning about, right? Energy cannot be magically added to the universe. It can't be magically deleted from the universe. So the only options are to transfer it or to move it from one place to another place and change its form. All right, this is going to be number 3 in your ticket. Give me a green check when you have it saved. You have 30 seconds. And this is also related to 2 questions in your quiz. Right, the kinetic theory of matter, talking about transferring energy, that's related to 7 and 8 in your quiz today. Is this helpful for you guys to be able to see these related to boxes? I figured I'd try it out, but if it's not helpful for you, I don't have to keep doing it. All right, again, fill in the blank with the word transfer. Give me a green check. Thank you, Alicia. Waiting on Amir, Tony, Ashton, Bree, Chanel, Damien, Dolly, Dusty, Dree, Dylan, Efren, Isaiah, Ethan, Jackie, Jessica, Justin, Matt, Miguel, Rozzy, Tristan, Whitney, Yolese. The word transfer goes in the blank for number 3 in your attendance ticket. Yep, this right here, number 3 in your attendance ticket, the blank should be filled in with the word transfer. All right, moving on in 5 seconds, everyone, because we've only got a couple minutes left. Looking good. All right, let's keep on going. Okay, so the reason the kinetic theory of matter is important is because it explains the behavior of gases. All right, so when you hear about pressure, what pressure is it's when gas molecules are exerting a force on their container as they literally collide with their container walls. Okay, so again, molecules are moving around really fast in gases, and so they will actually hit the sides of their containers. And if they hit their containers too much, what do you think is going to happen to those container walls? Tell me in the chat box. If those molecules begin exerting lots and lots of pressure on the container walls, what do you think will happen to that container? We mentioned this a little bit earlier in class today. What do you think happens when they begin to collide too much with their walls? Yes, an explosion, exactly. So when there's too many collisions, there's so much pressure that sometimes it can actually cause an explosion. All right, this is number 4 in your ticket. Go ahead, give me a green check when you have it saved. You have 30 seconds, and then I will give you your last word once we're done with that. And this will be related to number 9 in your quiz. Go, go, go. Fill in the blank for number 4 with the word collide. All right. Amir, Tony, Ashton, Bree, Chanel, Dusty, Donnie, Dorian, Dree, Dylan, green checks. Thank you, Jacob, Letty. Perfect. All right. Here we go. All right, so we talked about the states of matter, we talked about how they can change, we talked about how heat is absorbed and released, and we talked about the kinetic theory of matter. Lots of stuff. All right, I'm going to go ahead and send you the links to your quiz really quickly. All right. All right, so here's the links to your quiz. Again, all of those attendance tickets are related to the quiz questions as well. So those green boxes that we went over, those are the quiz questions that your attendance ticket is related to. So do them side by side and then submit them at the same time. Here's your last word. Thanks so much. Have a wonderful weekend. Bye, everyone. If you celebrate Easter, have a great Easter. You guys are awesome. See you all later. Bye.